Hey guys, Ben up here, and I'm going to show you how to do experimental and theoretical probability. Let's begin. Okay, first, the question is, the spinner below shows 5 equal-sized slices. Martina spun the dial 1,000 times and got the following results. So, the outcomes are gray, white, and black, and the number of spins. Gray had 582 times was landed on. White was landed on 202 times, and black was landed on 216 times. From Martha's results, compute the experimental probability of landing on white. Well, the first thing you need to know, it asks for experimental probability. Well, every time it asks for experimental probability, you will use the chart. Why? Because it's an experiment, and every time you do an experiment, you always put your data on a chart. So that's why we're going to use the chart, not the circle. The circle is not here. Okay, ignore the circle. Ignore it. It's not there. Okay, from landing on white. It asks to land on white. And this is white. So white, oh wait, let me erase that. That's white. White was landed on 202 times. But she spun the dial 1,000 times. So we're going to put 1,000 right below. And then we're going to change that into a decimal. 202, since there's 3 zeros, going to go back 1, 2, 3. So the decimal is 0.202. So that's the results of landing on white. So let's go to the next question. B. Assuming that the spinner is fair, compute the theoretical probability of landing on white. Well, first thing is theoretical probability. In this one, you do not use the chart at all. At all, it's theoretical. Theoretical does not use any experimental data. So you're just theoretical is by theory. So you're just going to look based on this picture right here. So basically, it says theoretical probability of landing on white. We have 1, 2, 3, 4, 5 spaces. And it says landing on white. So basically, it's going to be 1 over 5. And we all know 1 over 5 in decimal form is basically 0.2. Yeah, it's just basically 0.2. So, the theoretical probability of landing on white is 1 over 5 or 0.2. Those zeros are just placeholders. Now, let's go to the last question. The spinner below shows, okay, we already read that, I'm sorry. Assuming that the spinner is fair, choose the statement below that is true. Well, with a large number of spins, there must be no difference between the experimental probability and the theoretical probability. Well, that's a lie. How? Because look, the question says must be no difference between the experimental and theoretical. On the experimental, there is 0.202. On the theoretical, there is 0.2. There's a difference. So this one is out. On the second one, it says with a large number of spins, there might be a difference between the experimental and theoretical probability, but the difference should be small. Let's go back. Let's highlight. There might be a difference between the experimental and theoretical probability, but the difference should be small. Let's go back and check. Experimental is 0.202 to 02. Every time I said oh, I meant 0. I'm sorry. 0.202. The next is 0.200. So just 0.2 basically. Then, so there is a small difference. The difference is 0.002. As you can see, 0.202 and 0.200. So there's a difference. So we'll keep that checked. With a large, and the last one says with a large number of spins, remember, large number of spins, there must be a large difference between the experimental and theoretical probabilities. We all can say there's not a large difference between 0.202 and 0.2. So basically, the last one is also wrong. And the answer is the one in the middle. The answer is the one in the middle. With a large number of spins, there must be a difference between the experimental and the theoretical probability, because you see the difference is 0.2 and 0.202. Well, I'm Ben, and I'll see you, and I thank you for staying with me here to learn experimental and theoretical probability. And I'll see you guys when I see you guys. Peace.